Hello there, ROS developers, and welcome to a new open class number 165. And today we are going to be talking a little bit about navigation too. So ROS2 Navigation, a concept which is a little bit more advanced, which is navigation plugins and how to create your own custom plugin for navigation too. Okay? This is a quite advanced topic. However, I'm going to try to make it simple and give only the guidelines as what would be or how would look like this process of creating your custom plugin for navigation too. All right. So yeah, let's not lose any more time and let's get started. So let me switch already to my computer screen and please let me know if everything is fine, if image is fine, sound is fine, so that we can continue. So let me come here to my computer screen. There we go. Let me log in and go myself here to the class page so that I can see your comments and everything. Luis Manuel says, "Hello Alberto, you seem to be bouncing." Oh, you mean the camera? Oh yeah, it's right. Yeah, you're right. This is a bit strange. There is some kind of bouncing. Yeah. We'll need to check this. Why it is happening? Yeah. So thanks for your feedback, Luis. Yeah. So far, right now I cannot do anything, but. Yeah, I'll take note of it and see if we can get it fixed. Because I can promise you that I'm not moving at all, okay? It's not me that I am bouncing here in the chair. It's some kind of effect, probably from the camera or whatever. All right, then, yeah, so let's get started. As always, the first thing that you need to do is to get the rosject for today's class. And as I always say, this is very simple. All you have to do is to click here on this button right above the chat, which says fork, and open the class rosject. Okay, so I'm going to click here myself. Let me do it right now. So all of you, please click here so that you get the class rosject. Then, yeah, so with this, just to remind you, this by clicking on this button, what's going to happen is that you're going to get a copy of this rosject into your account. Yeah, so a copy of this rosject that I have created is going to be stored into your workspace, into your account. So you are going to have this rosject forever. Okay, not only for today's class, but if you want to access the rosject next week, next month, you are going to have it there also. Okay. And yeah, so also this is going to bring you here to the rosject page, the one that I am right now, here with the streaming panel at the right side, with the video feed, the chat, so that you can type any comments, questions, whatever. Yeah, and the rosject, which is currently being loaded right now. Okay. Then whoop whoop whoop. Here it's opening everything. Let me close things. There we go. Yeah, and automatically you should see as well here the Jupyter notebook opened for you. Okay. Yeah. Have you opened the rosject? Yes, no? Any issues so far? Are you following? Yes, says Luis. Okay. All right. So yeah. So today we are going to see. Yeah, we are not going to be able to get into super detail because that would require a lot of time. But we are going to go and follow all the steps, at least to get a general idea of the process of creating your custom plugin for ROS2 Navigation. Okay. Then, first of all, do you know what are plugins? What these plugins are? What they are used for? Does somebody know? Yes, no, no idea. Luis Manuel says, it's a piece of software to extend the functionality. Yeah. That's a valid definition, yeah. So we can think of these plugins as programs, let's say, or pieces of program, kind of libraries, yeah, as libraries that allow us to extend the functionality of. Here, Walter says, add custom functionality to nav2 modules. Yeah. So yeah, they are pieces of software or libraries that allow us to extend and, let's say, also customize and flexibilize the functionality of Navigation 2. Yeah. So Navigation 2 as a module, let's say, can be. We can customize, modify, tune the functionality of Navigation 2 by just changing the plugins we are using. Yeah, and this gives a lot of flexibility to us. Yeah, because it allows us to change the behavior of Navigation 2 depending on which plugin we use, right? So yeah, I see that you have this idea already. You know what a plugin is, more or less, and why they are so useful and why they are used for. So, as you may already know, then there exists a bunch of plugins already for Navigation 2. Yeah, I have pasted a list here. You have a link here in section 1.1, default plugins. You can click here. And here you're going to see a list of all the navigation plugins that are available by default. Okay, so you have plugins for the behavior tree navigator, for the cost maps, for the controllers, the planners. You have a bunch of different plugins which are available that you can use out of the box. Okay. Yeah. For instance, let's have a look. So yeah, let's just start with some practice already. Okay, then the first thing we are going to do is to launch the simulation. All right, a ROS2 based simulation. So in order to launch the simulation, you have all the instructions here in the notebook as well. So what you need to do is just to execute these two commands here. All right, then the first thing we are going to do is to open a terminal, a shell, by clicking in the first icon that you have here in the bottom bar. Okay? So I'm going to click here myself, and as you can see, this opens an empty, a blank terminal. All right? Then here we are going to copy the first command from the notebook. Yeah, you can select it and copy it with Ctrl-C, for instance, with a shortcut, and then paste it directly here into the shell. Yeah? And then I'm going to do the same with the second command, which is basically to execute this bash script. Yeah, this start basic robotic sim bash script. Okay? Now let me execute this, and this is going to start running the commands in order to launch a gazebo simulation. Yeah? Here it has already opened the gazebo window, so after some seconds we should be able to see here the simulation. And here we have it. Yeah? Here we have the simulation with this Robotics NP400 robot in this environment. Okay? Yeah, so let's just start by launching this simulation. All right. Now, in order to be able to properly test these plugins, or to even create our own custom plugin and test it, we need to have a navigation system ready and working, right? If we don't have this navigation system working, we are not going to be able to load our custom plugin into the navigation system, right? So the first thing that we need is to have this navigation system properly configured and working for our robot. right? In this case, this is already prepared for you, so we don't have to create and configure the navigation system. Yeah, this is already done in this rosject. So let's open now. Then, before we actually run it, let's open the code editor. Okay, the code editor is you can open the code editor by clicking in this second button, also here in the bottom bar. Okay, which is code editor. I'm going to click here myself, and this is going to open the code editor, which basically is going to provide you a graphical interface, so that you can visualize and navigate through all the folders, files of this rosject. Okay. In this case, the workspace that we are interested in is the ROS2 workspace. Here is where all the important files, folders, packages are placed. Yeah. So here inside the ROS2 workspace, you are going to find here a couple of packages which are used for the simulation. And then we have also this other folder, Robotics NP400 Navigation. Okay. If you get inside here, you are going to see all the packages that are already prepared and configured for launching the navigation system of this robot. Okay? Yeah? Then we can just to make sure that the navigation system is working, we can run it. Okay? We can launch it. So for this, let's leave our simulation running here in the first terminal. Okay? Don't close it, because otherwise the simulation is going to die, and we don't want that. So let's just leave here the simulation running in the first terminal, and then let's open a second terminal here, where we are going to launch, in this case, the localization system. Yeah. This first command that you have here, you can as well select it from the notebook directly and run it here into the second terminal. Okay. And this is going to start the localization system for our robot. Okay, there we go. And as you can see, it has automatically opened here as well another window where we can see RVs. Okay. Yeah, this is the graphical tools window, which is used to visualize graphical applications such as RVs, RQT. Yeah, all these graphical applications, you are going to be able to see them, to visualize them through this graphical tools window. Okay. All right. So we have our localization system running here, and then the second step here is to launch the path planning system, right? Which is this second command here. So again, I'm going to open a third terminal. Yeah. And in this new terminal is where I am going to run the path planner system. Okay. So I'm going to copy the command again here from the notebook and paste it into this new terminal. All right? There we go. Okay. All right, so we have in the first terminal here the gazebo simulation running, in the second terminal the localization system, and in the third terminal, the path planning system. Okay? Then now, in order to properly visualize the path planning, that we can visualize, for instance, the cost maps, you can load them manually here and add the displays here to RVs, okay? But I have also prepared an RVs file that you can directly load here. Yeah, it's this pathplanning.rvs file, which is inside the Path Planner server package, okay? So in order to load this RVs configuration file, you can come here in ROS2 file, then open config, okay? Now here you need to navigate to the ROS2 workspace, SRC, Robotics NP400 Navigation, Path Planner server, RVs config, and here you have the file, okay? Sorry. Then once you have the path planning.rbs file, you click on open, discard, for instance, and then this loads the configuration file for RVs. Yeah. Now here you can visualize the global cost map, local cost map, everything. Okay. Yeah. So you have the global cost map, and the local cost map in this case is not showing, probably because I'm far away here from the obstacle. Okay. Then, in order to make sure that everything is working, you can, if you want, send a navigation to goalposts, wherever, for instance here, and then we should see our robot navigating there. Okay. If you go to the simulation, you are going to see as well the robot here, which is moving towards the goal. Okay? So, what does this mean? This means that our navigation system is working properly. Okay? We have a navigation system here in the rosject that is working properly. Okay? So, after doing these tests, you can, if you want, you can see here the last message from the path planner, which says goal succeeded. Okay? Then we can stop already the navigation system for now. We have launched the nav2 system, and we have tested that it's working okay. Yeah. Then our current navigation system is already using plugins, right? So let's have a quick look just to try to identify the plugins that we are using. Yeah. For instance, here inside the path planner server, if you go inside the config folder, we can open, let's say, the the planner server.yalm file. Okay. This is the configuration file that we are running for the path that we are loading for the path planner node. Okay. Then we can open this YALM file here, and we can see, for instance, in the global cost maps that we are using several plugins already, right? So here there is a parameter which is named plugins, and here we can see that we are using a plugin static layer, obstacle layer, and inflation layer, right? And then down here we have all these plugins properly configured, right? So for instance, for the static layer, we are actually loading this plugin, this nav2 cost map 2D static layer, right? For the inflation layer, we are loading this nav2 cost map 2D inflation layer. Yeah? These cost maps are the ones that we saw previously that are provided out of the box by Navigation 2. Yeah? So if we come here to the list of navigation plugins, we can see this static layer plugin, obstacle layer, inflation layer. Yeah? So all these plugins are the plugins that we are using here. Yeah? So far, so good. Are you following the explanation? Are you following the steps? Are you getting lost? Yes, says Iván Bermejo. Okay. Also Fred says, yeah. Okay. So I understand that you are following, but the robot don't move. If it doesn't move, probably it's that you missed some step. Okay, Ivan? Oops, sorry. I click on your name here. Okay, so review the steps. Yeah, so you need you need to launch the simulation first of all. Okay, then once you have the simulation running and loaded here, you launch first the localization system with this command, and second you launch the path planner system. Okay, if you follow these steps, everything should work okay. Okay, as you have seen here. All right, then, okay, so of course, in most of the cases, for most of the robots, you are going to be able to have the robot properly navigating by using the default plugins, yeah? Like it is our case. So our robot here, it's navigating, as you have seen, by just using default plugins, okay? But there is the option to create your own custom plugins, okay? So besides the default ones provided by Navigation 2, you can even create your own custom plugins, yeah? And the process of creating a custom plugin can be a little bit complicated, especially for new users, yeah? For users which are not experienced in programming or in ROS2, okay? Then basically, the process of creating a plugin is done by overriding specific functions, okay? So let's do okay. Yeah, let's just start with the process, and meanwhile we are creating our own custom plugin. I'm going to try to explain all the steps, okay? So that you understand at least the general idea, okay? Then the first thing that we are going to do here is to create a package, okay? We are going to create a new package here in our workspace where we are going to generate our new custom plugin, okay? Then, yeah, so let's start by step 1 and create our new package, all right? So let's first of all go to the src folder of the ROS2 workspace. Let me minimize everything here, okay? Let's come, for instance, to this terminal. And here, I'm going to run all these commands, okay, in order to generate my new package. There we go. Okay, so I have created my new package. I'm going to build it now. Just to do an initial build of my package and have it ready. Okay, there we go. We are building this custom nav2 cosmap plugin package. Yeah. So here, here you can see the command that I have used to create the package. So ROS2 package create. It's an amend CMake package, so it's a CMake package. This is the name of the package, which is custom nav2 cosmap plugin, and then at the end I add the dependencies. Okay, very important in this case to add the nav2 cosmap 2D and plugin lib dependencies. Yeah, plugin lib in order to create the plugin library, and this one in order to, because in this case we are going to create a plugin for cosmaps, okay? There we go, we have compiled, we source, and there we go, okay? So now, for instance, if you come to the code editor here, you are going to see that you have a new package here in your workspace, okay? Then, our plugin is going to have two files. Yeah, we are going to have a header file where we define all the different methods that our plugin is going to have, and then we have the source file, which is where we actually implement these methods. Okay? If you are familiar with C++ programming, then you know that any library is divided into the header file and the source file. Okay? Then let's create these two files, the source file and the header file for our plugin. Then let's come here inside our package, create first of all the CPP file with the touch command, and create the header file again with the touch command, okay? There we go. Then our source file is going to be inside the src folder, and as you can see, it uses the CPP extension, okay? And the header file is going to be placed inside the include folder, okay? And it uses the extension HPP, okay? Then let's continue by adding the contents to this file, yeah? Because right now these files are empty, right? We have just created them. So if I open the header file, for instance, it's completely empty, okay? So what we are going to do is to come here to the notebook and select the contents. In this case, these are the contents for the header file, okay? So we are going to come here, select all the code from the notebook, copy it, and then paste it to the file here in our code editor, okay? Yeah? So far, so good. Are you following the steps? More or less, yes, no? Do you understand what I am doing? I'm not getting feedback now. So I don't know if you got completely lost with these last steps. Yes, says Sajid. Also Fred, yes, okay. All right, Fernanda, okay, perfect. All right, so just to clarify, thank you for this simple explanation. Yeah, so just to clarify, at some points maybe I am going too fast. Yeah, so the thing here is that we have limited time, okay? So I'm going to try to go over all the steps so that you get a general idea. Yeah, so obviously it's impossible to go into all the details within 1 hour. Yeah, but my goal here is that you get a general idea. Okay, then later, if you want, you can go step by step, checking everything. So you have most of the information. You have it here in the notebook as well. Okay, so you can have a look more slowly to all the codes, etc. Okay, remember that this rosject you are going to have it forever in your account. Okay. Then, yeah, so here there are some things in the header file, some points that I want to mention. First of all, we need to declare a namespace, yeah, a namespace for our plugin so that we can differentiate our plugin from other plugins, yeah. In this case, the namespace that we are using for our plugin is this one, yeah, custom nav2 cosmap plugin, okay. Then the second important thing to see from this code is this line here. Yeah. So our plugin is defined. We are going to define it in a class which is named like this: gradient layer, right? But the important point here is that this class inherits from this parent class, which is layer. Okay? Yeah? So our class inherits, so our class is a child of the layer class. Yeah? Oops. Okay. My code editor refreshed here, okay? But This is not something that I am doing in my class because I want to, okay? So if we have a look, for instance, to the plugins for the navigation to plugins that are provided by the navigation to system, yeah. For instance, if we have a look at the static layer, yeah, which is a plugin that, oops, sorry, I don't know about this, yeah. If we have a look at the static layer plugin, which is one of the plugins provided by default by the navigation to system, we are going to see here also, well, let me see, yeah, not in the source file, but in the header file. Let me go to the header file here in include static layer, okay? Where it is here. All right, I don't find it right now, but the thing is that this code, as you can see, it has a series of virtual functions. Okay, so do you know what a virtual function is? Yes, no? Do we save the file? Yeah, you can save it. In any case, it's saved automatically. So do you know what these virtual functions are? Oh yeah, here it is. So the static layer class, in this case, inherits from the COSMAP layer. Okay? And the COSMAP layer, if we have a look, probably here, here we have the header file for the COSMAP layer. This one is going to inherit from layer, yes, which is the same one that our class is inheriting. Okay? No, don't remember, an interface, no, says Fernanda Rodriguez. Okay, so this is an important point to try to explain, okay? I'm going to explain it in very simple terms, okay? But this is known as overriding in C++ programming, okay? This concept is known as overriding. What does override mean? Override means that this parent class, which in this case is layer, is going to define a series of methods which have to be overridden by the child class. Okay? And these methods that are overridden are known as virtual methods. Okay? So here in the source code of navigation, if we have a look at the layer header file, which we can see it here, layer HPP. This is the header file of the layer class. Okay? If we have a look here at the header file of the layer class, we are going to see that it defines a series of functions as virtual. See? Virtual void deactivate, virtual void reset, virtual void update bounds, yeah? Virtual void update costs, virtual void match size, okay? So all this, also virtual void on footprint change, okay? So what does this mean? This means that all the functions that are defined here as virtual in the parent class, in this layer class, can be redefined, overridden by the child class, which in this case is the gradient layer class. It's the class that we are creating. Okay? Yeah? So this is what a virtual function is. Okay? In very summarized. Okay? So that you get this general idea. Then, what happens here? Let's move down here a little bit, yeah? So, some of these functions that we have seen that are defined as virtual, some of them are required and some of them are not required, yeah? What does this mean? That some of them, we have to implement them mandatory in our child class, yeah? So these methods which are required, we have to define them, we have to implement them, yes or yes, in our child class, okay? The ones which are not required, we don't have to define them, okay? And if we don't define them in our, for instance, this match size method, we don't have it implemented in our class, see? In our class, in our gradient layer class, in our child class, we are defining onInitialize, update bounds, update costs, reset, on footprint change, and is clearable. Yeah, all these methods we are defining them in our child class. Yeah, but for instance, this match size we are not defining them. Why? Because it is not required. So if we don't define it, then it's going to use the default implementation of the function, which is the one defined in the layer parent class. Okay, does this make sense, more or less? Do you get this general idea? Yes, no, more or less? Okay, this is a complex topic in C++ programming, okay? But at least it's okay if you get the general idea. Okay? So when you create a custom plugin, you are going to have to take into account the parent class that you are going to use, okay? And you have to take this into account in order to implement in your child class the methods which are required, okay? Of course, you can also implement your own, the own methods of your class, which have nothing to do with the parent class, okay? Of course, you can also do that, but you are going to have to always implement some methods, some virtual methods which are defined in the parent class, okay? Then, let's continue to create, MP, how do we know which functions are not required? Yeah, so for this you are going to have to look into the documentation. Okay, the documentation of the parent class. Yeah, so this information should be provided to you. Yeah, if not, you are going to have to go and look at the source code directly. Okay. So okay, let's create now the source file with the same method. So come here to the notebook, select the code, and paste it here to our CPP file. Okay, there we go. Now in this file is where we are actually implementing the methods. Yeah. So here, as you can see, we are just defining them. We are defining all the methods, but we are actually not implementing them, okay? Here in the source file is where we are actually putting the code, okay, to implement all these methods. Yeah, for instance, here we have the implementation of the onInitialize method. Yeah, the implementation of the update bounds method. Yeah, the implementation of the onFootprint changed, okay? So all these methods I'm not going to get into detail. You can have a look here at the comments to see what each one of these methods does, okay? Yeah, but I'm not going to get into so much detail. Basically, what we are doing here is to update the costs of the cost map to the maximum values. Okay? So we are going to put all the costs to the maximum values. Yeah, you can see it here. Okay, so we are updating all the bounds to the maximum values. All right? Then in this file is where we are actually implementing the methods of our plugin. All right? Here you have some more explanation in case that you want to have a look more in detail, okay? I'm not going to go into all the detail of what all this code is doing because this is pure CPP coding, okay? But what I am interested more in this class is that you get the general idea of how to create your custom plugin, okay? Not about the specific implementation of the methods and all this. So all that you can check it by your own later with more time. Okay? All right, then there is also one important thing, which is to export the plugin. Yeah, this is at the end of the file here. Yeah. So this is a macro. Yeah. This is a macro that you have to use in order to be able to export your plugin. Yes? So this is also important when you are creating plugins. All right? Then let's continue. So let's continue with step 3. Once you have created your header file and the source file for your plugin, the next step is to create the XML plugin file. Okay? This is very simple. All you have to do is to go to your package here and create this XML file, okay? The name can be whatever you want. In this case, it's gradient layer XML, okay? And then in this file, you are going to specify the following information. You have it here, so I'm going to copy it and paste it here directly to the XML, okay? Then here you have information about how to load your library, your plugin, okay? So the path, where is this plugin located? Yeah, this is the path, the name, okay? And a brief description of your plugin, okay? So this file is required so that the ROS2 system is able to find and load your plugin. Okay? So here you have all the information, specific information of what each tag does. Yeah. So library path, of course, this is the name that you give the library when you compile it. When we compile it and when we set this name in the CMakeList.txt file that we are going to do next. So this is the name you set. Yeah. The class type, which states the plugin namespace, and the custom class, you define it in the CPP and header files. Yeah? Yeah, also, here, as you can see, in the class name, we specify the type, and we specify also the base class type, which is layer. Yeah? Remember, this is the parent class. Okay. Then step 4 is to actually compile our code. Yeah. So now we have already created the source and header files, the XML plugin information file, and now we have to prepare our CMakeList.txt in order to compile and generate our plugin. Yeah. So for this, we need to make some modifications here in the CMakeList.txt file. Yeah. Then in this case, we are going to get the contents here again from the notebook directly, and we are going to comment on the important parts of this file. Okay. So there are some important parts here. Yeah. So first step is to set the library name. Yeah. We do this using this set function. Yeah. So here we are setting this variable lib name, which is going to have the following value: project name core underscore core. Yes. So this lib name is going to be equal to project name, which is custom nav2 cosmap plugin plus core. Yeah. So basically this means that, let me write it here. Lib name is equal to the project name, which is this, plus underscore core. Yeah? So this is going to be the name for our library, for our plugin. Okay? Then, yeah, here we have it. Yeah, this is the name that we use that we have used it before in our XML file. Yeah? Here in this file, if you remember, this is the name that we are using here. Yeah? Then, next is to set the dependencies. Yeah? So our plugin is going to have certain dependencies, and we are setting these dependencies here. Yes? Here is where we are setting the dependencies of our library. Yes? Which are RCL CPP, nav2 cosmap 2D, and plugin lib. Yeah? Next, add the library. Here is where we are going to actually generate the library. Yes? We have it here, yeah? So here we are going to generate a library which is going to have lib name. It's going to be named as lib name, yeah? Remember that lib name is this, yeah? And this library is going to be generated from this CPP file, gradient layer.cpp, which is the CPP file that we have created here. Yes? So this file is going to be compiled, and we are going to generate a library from this source file. Yes? Important to include here the include directory, because it's where we have the header file. Yeah? So we need to include this directory, the include directory, this one here. Yeah? Otherwise, the building system is not going to be able to find the header file. Okay? And finally, we, well, not finally, but almost finally, we install our library. Okay? We have to install it into the ROS2 system. Yeah? And then at the end, we export our plugin by using here the XML file that we have generated previously. Okay? Yeah, so set dependencies, add the library, include the folder, the include folder, we have already mentioned that. We install the library in the system. Then we, so we export our plugin so that it is available and the plugin system can find it. And finally, here we are linking the dependencies from the library. Yeah, we are linking our library with the dependencies that we have defined above here, if you remember. Yeah. Okay. So this is the process in order to generate and make our plugin, our library, available for the system. All right. Then there is one last step only missing, which is to update the package XML. Okay? Actually, in the package XML, let me open it right here. All we have to do is to add here in the export section this line. Yeah? So in the export section, we need to add this line here. Okay? Which is pointing to the path of the XML file that defines my plugin. Yeah? This is the gradient layer XML. Yeah, so we have to add here the path to, oops, sorry. Let me put it again, yeah? We need to add here the path to the plugin information file that we have generated previously. Okay? And we are almost there. Okay, there's one more thing that we need to do. So right now we can already compile. So let me already compile here to see if everything is good so far. Let me try to compile here. Well, actually, let me just try to compile colcon build packages select and put the name of my package here. Let's see if this compiles successfully, if my plugin compiles properly, which means that so far I have done all the steps correctly, okay? Then once I have built my package, so I have built my custom plugin, there is one last step. Which one it is, the last step that we need to do? Can somebody tell me? What is the last step that I need to do once I have my plugin generated? Seun is asking, will there be a replay of this class? Yes. Yes, Seun. So for everybody who's asking, we are going to update this class to YouTube, okay, when it finishes. So you are going to be able to replay it as many times as you want. Launch a new simulation. Not exactly. MP says, add it to the nav2 config. Exactly. That's it. So now we have already built, as you can see, I have already built my custom plugin, but in order to use it, I need to actually load it into the navigation system, right? So let's do this, okay? This is the last step. Then my plugin is a COSMAP plugin, right? So where I am going to add it? Well, I will have to add it to the global COSMAP configuration and local COSMAP configuration, right? Those are the places where I can load my custom COSMAP plugin, right? So if I want to use it, I'm going to need to come here to the navigation packages, to the path planner server, right? And to the, let me close already all this for now, and come to the, for instance, to the planner server configuration, right? Here in the planner server is where I have the global COSMAP configuration, right? Yeah? So here, if I want to use my plugin, I'm going to have to add it where? Here? Yeah, it looks like, right? So if I want to load my plugin, probably I'm going to have to load it here, right? So let me comment this line here. Let me comment this line and generate a new one here. Yeah. And then, what is all this? Yeah, no, forget about this. I'm going to ignore this. I'm going to do it directly. Yeah, I'm going to skip all this and load it directly in our current configuration files. Okay, so here, yeah, if I want to add it to the planner server, for instance, I'm going to have to add it. And in this case, I'm going to substitute it by the inflation layer, okay? Here, instead of the inflation layer, I'm going to load my own custom gradient layer. Okay? Yeah, and then I have to specify the parameters for my plugin, which are these ones here. Yes, so here I add the specific parameters for my plugin. Yeah, so this is the name that I am giving, but here is where I put the path to my specific plugin. Yeah, which is custom nav to Cosma plugin gradient layer. Yes, so this name can be whatever you want. Yeah, here it is custom gradient layer, but it can be anything that you want. Yeah, this name here is not important. The important is that you put here the path to your custom plugin. Yeah, and of course you have to set enable it to true. Yeah, does this make sense, what I am doing? Yeah, do you understand why I am changing this here? Yes, no? Yes, says MP. Yeah. Yes. So this inflation layer that I was using previously, this inflation layer is loading this this specific plugin. Yes, which is one of the plugins provided by default by navigation. Yeah. So now what I have done is to deactivate this plugin, the inflation layer plugin. I have deactivated this one, and instead I am loading my custom one, which is here defined. Yes. Then this is for the global cost map, but we can change it as well for the local cost map. Yeah, the local cost map configuration is inside the controller YARN file. If we go down here, we have the local cost map configuration. Yeah, so for the local cost map configuration, we can basically do the same. Yes, so I'm going to add here. So I'm going to comment the current plugins line, which is here, and I'm going to again substitute the inflation layer by my own layer. Yes, and of course I need to also specify the path to the plugin. Yes. Yes, so I have done exactly the same. For the local cost map, I have substituted the inflation layer by my custom, by my custom plugin, okay? And it's the same configuration. I am using the same for both the local cost map and the global cost map, okay? All right, so let's compile then. Let's compile everything again because I have changed the configuration file, so I need to recompile the system. So let's recompile. Source. Okay. Actually, I'm going to restart the simulation as well. It's not needed, but I'm going to restart it. So let's restart from zero the simulation as well. Okay, there we go. Now, let's launch the localization system. Oops. In the first shell here. There we go. Okay, here we have the localization system. And let's load the path planning system, okay? Let me source the workspace before launching the path planning system, okay? So that I make sure that I'm getting the latest files. Launch the path planner, there we go. Yeah, this is wrong. This is not. It's okay. Yeah, it's not this, but it's actually just path planner, right? Path planner dot launch dot py. Yeah, it's only this. Okay, without all this. Okay. All right. So now, again, remember, in order to visualize all the cost maps and everything, let's open the path planner configuration file that you have here inside the path planner server. rvs config path planning. Okay, there we go. So what we have here is that all the map, as you can see, is completely full to the maximum cost. Yeah? Do you see do you remember the one that we had before? Yes. So actually now all the costs, so the costs here are maximum for the whole cost map. Yeah, can you see this? So what is going to happen, for instance, this is just a dummy example, of course, it doesn't make any sense to have cost maps like this. Yes? Why? Because if everything is using the maximum cost, the robot is not going to be able to move, right? So if I send a goal somewhere to the map, it's going to fail. Yeah? So actually, it fails and the robot, it doesn't move. Yes? Because there is no obstacle-free path to the goal. Yes? But what you can see here is that we have created a custom plugin, yes, which is setting the maximum cost to all the cost map, okay? And we are loading this custom plugin into the navigation system. Yes? Of course, navigation is going to fail here because it doesn't find any path without obstacles to the goal. Yeah, but this is because of how we have programmed our custom plugin. Yes? Yeah? Do you see the difference? Do you see that now we are loading the custom plugin? So let's try to summarize all this, okay? So let me already stop this, yeah? So let's try to summarize, okay? All the steps that we have followed very quickly before finishing the class, because this was the last part of the class, yeah? So, steps. Let's go over all the steps very quickly. Yeah, so the first step is to create your package, create a package where you are going to place your custom plugin, then create the source and header files, okay? Then, very important, when creating your source and header files, is to know which is going to be your parent class, okay? If you are going to build a custom plugin for cost maps, very likely your parent class is going to be layer, okay? And then you need to figure out which are the virtual functions that you need to define and to implement in your child class, okay? But if instead of a cost map layer you are going to create a controller plugin, then the parent class is going to be another one, yes? So the layer parent class only applies for cost map layers, okay? If you are going to create a planner plugin or a controller plugin, then the parent class is going to be another one, which is going to have other virtual functions, okay? So depending on the plugin you create, you need to get this information of what is the parent class that you are going to use and what are the methods that you need to override in your child class, okay? Then with this information, you create the header and source files for your custom plugin, okay? Once you have the header and source files for your plugin, you have to create the plugin information file. Yes, which is this XML file. Okay. Next step is to build your library. Yeah, so you need to modify the cmakelist.txt file and package XML file so that you can, so that your new plugin, your new library is built correctly. Okay. And then once you have built correctly your plugin, the final step is to actually use it in your navigation 2 configuration and load it wherever it is needed. Yeah. So if it is a cost map plugin, then you are going to use it, of course, in the global cost map configuration or in the local cost map configuration. If it is a controller plugin, then you are going to use it in the controller server configuration, right? So you would change the plugin here. Yeah, you would load your custom plugin here. Yes. So here, the follow path plugin is loading this DWB core, DWB local planner. Yes. So here you could define your own plugin. Yes, and load it in the controller server configuration. Yeah. Does it make sense, more or less? Did you get the general idea? Yes, no? Yes, says Mohammed. Somewhat, says Seun. Yeah, so this is a complex. This is a pretty complex topic. Okay. Then which it's very hard to cover in just the time that we have in an open class. Okay. So in case that you want to get more context, get more information about all this, I have left you here at the bottom of the notebook a couple of links. First one is the ROS2 Navigation course, a link to the ROS2 Navigation course where you can learn everything about ROS2 Navigation, from localization to path planning, how to configure all the navigation system for any robot. Okay, and also I have added here a link to the advanced ROS2 Navigation course. Yeah, this course covers more advanced topics such as these plugins. Okay, so in this course, specifically in this unit, the one for plugins, you are going to find more detailed information about all this process of creating a plugin. Yeah, here there's no time to go over everything, but in this course, in the advanced ROS2 Navigation, you are going to find much more information related to custom plugin creation and to other things, okay? Other advanced navigation to topics, all right? David says, almost lost with the YALM part, could not find it. Must have missed a step. A good class, thanks, says Ivan Remejo. Okay, yeah, David, so the YALM file is, you can find them here, yes? It's, if you go to ROS2 Workspace SRC, you are going to see here the Robotics MP400 navigation, yeah? You open here, and then here you are going to find the navigation, the nav2 packages. In this case, if you go inside the Path Planner server, and inside the config folder, here is where you are going to find the YALM files, okay? The ones that I have modified in order to load my custom plugin. Okay? So, yeah, then let's leave it already here. Thanks a lot to all of you for being here with me in another class. I hope that you've learned something. Remember that this rosject, you are going to have it for you. So you can revisit it, you can reopen it tomorrow, in 2 days, next week, whenever you want, okay? And also, we are going to upload right in a few minutes the class to YouTube, okay? Just in case that you want to rewatch it and pause it to to go at a slower pace, you can also do it by going to our YouTube channel. All right. Then, yeah, that's all for today's class. Thanks a lot. I will see you again next Tuesday with another open class. And as always, until then, take care and keep pushing your ROS learning. Bye-bye.